Hello everybody, I'll give you a presentation on OBIS, the Ocean Biogeographic Information System. And I will focus my talk on some of the phytoplankton data we have. So to start with, OBIS was initiated by the Census of Marine Life in 2000 and was adopted by the IOC member states in 2009 and started as a project of IOD in 2011. At the moment, we have an international secretariat at the IOD office in Ostend, and we have 27 OBIS nodes, which are connecting to 600 institutions. We have 47 million observations of 120,000 marine species. And we are growing at a rate of about 3 to 4 million records every year. So this is an overview of the data providers and the 27 OBIS nodes. They can be national, they can be regional, and they can be thematic. So how does this work? The data providers have their data sets on files. Then the OBIS nodes, they harmonize the data, they quality control the data, and they map the data to Darwin Core, and they publish them through the IPT, which is software server that they host or that we host here at the OBIS Secretariat. Then international OBIS, we harvest these OBIS nodes, we harvest the files from these nodes, we integrate these data sets and we index them and we quality control them. So we index them by taxonomy, by geography, by time, by depth, by environmental parameters that we get from World Ocean Database. And then we provide that integrated database through a web portal, which is connected through our API and the OGC web services. We've also recently built an R package. So this will allow our users to explore the data, to access the data, to download, to visualize, and to analyze the data. We looked into we have more than 1,000 papers at the moment that have cited OBIS, and we could trace about 500 in Web of Science, and we looked at how those co-author papers are linked to each other to see how much international collaboration there is looking at data from OBIS. So we discovered about 73 countries are using OBIS for their research publications. There's also nice connection between, you can see connections between the US, Europe, and Australia, but there's also south-north connections and south-south connections. So it really is a global effort in getting research out of OBIS, although the south connections and the south-north connections can still improve. OBIS is one of our main clients is scientific community. So we support science applications based on data from OBIS. For example, we recently released a new species trend index based on occupancy modeling, looking at the chance that a species is occupying particular sites. This example was on mollusks from the Celtic Sea, where we discovered that there was a 22% of decrease in site occupancy compared to 1985. Other examples are available on the OBIS website. Also, an important international process that we support is one from the Convention on Biological Diversity, the CBD, which identify through regional workshops areas that are ecologically or biologically significant, the EBSAs. And this is a process where the CBD member states asked IOC to support and to continue support this process. Another interesting process that we support are global assessments, such as the World Ocean Assessment under the UN, where a number of chapters use data from OBIS and referring to OBIS. Capacity development is is a very important aspect of our activity. So we organize one or OBIS course at the Secretariat, and these courses we kind of train the trainers here in Ostend, and then the trainers repeat those training courses in their own home institutions and countries. So we teach them how they can contribute data to OBIS, but also how they can get data out of OBIS to use for them to use for analysis. So have a look at our new portal, which we launched a few months ago. You can find statistics on countries, on particular areas beyond national jurisdiction, data sets, taxa, etc. One of the examples, when you go to a taxon like the Atlantic herring, you can see distribution maps, but there are some features like see where the first records are, to see where species are expanding their range, but you can also see last records to see where species are decreasing their range. So let's have a look at the phytoplankton data in OBIS, and we filtered OBIS based on the phytoplankton species list provided to us by WORMS, the World Register of Marine Species. So at the moment we have 2.5 million records of species occurrences of 2,326 species from 229 data sets, starting from 1700s up to 2014. So this maps gives you all the data sets color-coded by data set. We also created an interactive map where you can explore these data sets. So for example, if you want to know which data set this is, you click on a dot and you see the name of the data set, and there's a link to the dataset page on OBIS where you then can download a CSV file or a Darwin Core archive. So we also plotted the number of records for these more than 2,000 phytoplankton species, and of course there's a long tail of many species that have only a few records in OBIS. Also note that we have about 25% of the phytoplankton species covered in OBIS. WORMS list has more than 9,420 phytoplankton species. So if you filter down by those that have more than 3,000 records, then you get a more visible graph. And Serratium fusus is the champion with more than 100,000 observations in OBIS. If you look at the 229 phytoplankton datasets in OBIS and how many years that they cover, of course you can also see a long tail, but there are some datasets that really have a very nice and very long-term time series sets. So this is a filter by those that have more than 5 years, that span more than 5 years. And this global map shows you all the points of phytoplankton species occurrences, but by year, by last year that we have data from that position. So you can see that particularly in the southern hemisphere, there are very old records, and it's only those that are red, dark red, are actually still active these days, or more recent data. Then we kind of created time series stations in OBIS. So we aggregated all the data from OBIS, from the phytoplankton data in OBIS. We aggregated those by 6 by 6 minute grids. And then we plotted them on when they started to have data on the x-axis, and on the y-axis you have the number of data duration that they have data from, and the size of the dots corresponds to the number of records. So really in the early, the late 40s, 1950s, some of the very long-term time series stations started ticking off more than 50 years. But most of the stations have more than 10 years. Many stations have more than 10 years of data. Most of the stations have less than 1,000 records. Also nicely, you can see that since 1975, some of these long time series stations really have more than 10,000 records. That's probably because some more automated sampling took off. Then we looked at those time series stations that aggregated by 6-minute grids, but filtered those that have more than 5 years of data and see how many were added to OBIS and how much were lost. So the green ones are the stations, the new stations that were added. Red ones are those that we lost, and the black curve shows you the total number of stations with more than 5 years of data. So I think quite impressive to see that in the 70s, 80s, and 90s we have more than 10,000 of these long-term time series stations in OBIS. The fact that it's taking off is, yeah, of course, more than 5 years. There are no stations more than 5 years. Less than 5 years from now, and we're also losing more and more stations more recently, and that's probably because the time the time it takes to share data with OBIS. Another interesting paper that was published in Scientific Data Journal of Nature was on the marine phytoplankton database aggregated for Australia with more than 3.6 million records. And some of these data are already in OBIS, but those that are not yet in OBIS, I can already report that OBIS Australia is working on getting these into OBIS. Something I also want to mention is OBIS has, from the beginning, only dealt with species occurrences, but there's many more data that's being collected at the same time of the sampling event, and you also lose lots of valuable information that's inherent to the sampling event, like what sampling gear was used, where the subsamples, were their slices taken, were there replicates of the sample taken. And these things are very important to know, to interpret data such as abundance or biomass. So we are moving to a new format, a new OBIS schema, which is based on an event core, an occurrence extension, and a measurement effect extension. So the event core will have the sample information, the occurrences extension will have the occurrences, and the measurement effect extension will have all the measurements and all the sampling effects. So here's an example of the Doric terms that you can find in these 3 different files. So you have the sampling event, you'll have the event ID, you'll have a parent event ID to link to build a hierarchy of sampling events starting from, for example, a cruise, a station, a sample in a station, a subsample, etc. You have the event date, habitat information, depth information, the coordinate uncertainty, and footprint WKT is very useful when it's not just point information, but if you have line transects or polygons. Then the occurrence file have mostly the taxonomic information, and the measurement effect file has all the sampling effects, sampling gear, sampling volume, sample area, but also the abundances, the biomasses, but also abiotic measurements like temperature, salinity, all the physical chemical measurements sticking alongside, concurrent with the same sampling event. can all be stored in OBIS. An extra feature that we added is we want to have the measurement, the types, the values, and the units linked to a unique ID in the NERC vocabulary, which is widely adopted vocabulary for oceanographic data. And this will be useful to standardize all the data, and which is important when you integrate lots of data sets. So OBIS is moving from a biogeographic database to a more ecosystem database, or like Philip Goldstein mentioned at the OBIS steering group meeting, we're moving from the biogeographizoic area to the neo-eco data scene. And of course, I wish to thank all our sponsors and our contributors and the more than 1,000 scientists who contributed data to OBIS. Thank you.